Hello, this is Dr. James, and today I'm going to talk about building high-power audio oscillator circuits. Okay, and I guess this is in the way here. Make sure this is unplugged. Okay, so here is my high-power audio oscillator. I have some neat projects I want to do with that, using NPN transistors, and just testing it out before I put it into my audio circuit. Okay, it should be very interesting. I'll show you the circuit, show you how I build it, and let's get going. Okay, so here is our circuit for our high-power oscillator, and I'm going to add in dual tunable pots between these two, so I can increase the resistance. This is at the high frequency point, and I'm going to add, I think, about extra 10K to tune it down to the lower frequency point. And here are some of the parts that we have. Here's a 300 watt speaker, and I measured it about 6 ohms through my transformer, which I made a video about on how to build these. Here's my dual potentiometers in the bag, and I need some offset resistors, 200 ohms worth, right, for right here and right there. And I ordered these off of Amazon, and I was going to make a video about these, maybe I still will. 100 ohms, need about 4 of those. And I did order some 2N350 transistors, NPN, and I've been still waiting for them to come. So I got some NTE replacements, so I can build the circuit with those right now. These are basically the identical transistor, but the NTE replacement part. So I'm still waiting for the ones from Amazon, the 2N350s. And we'll just use these in the meantime. And I looked around for some capacitors. We needed about 0.2 microfarad to get in the frequency range that I wanted. And I found, I had stored up from Radio Shack. See, these two capacitors are the tuning capacitors. I stored up from Radio Shack some 0.22 microfarad capacitors. And I got some high power heat sinks, and I like to have sockets. I found these sockets around, and might be able to plug the transistors into those. And let's see what we can do. We'll see if we can get this circuit to oscillate. It should be interesting. Okay. Okay, so here's our NTE transistors, and let's try opening up one of these. Okay. Oh, come on, really? Tough package. Okay. And we'll try getting one of these out. Okay. I wonder if it will fit into this socket. I might need to get a different socket for this. Oh, there we go. I guess it does fit into there. Not quite right, though. Okay, I might need to get some other sockets then for this guy, because these aren't quite the right size. Maybe I'll just solder these in for now. Okay. See if they fit onto the heat sinks. Okay. Very cool, huh? Okay, so I guess I've been looking around for some sockets for the transistor. This is a TO3 type of casing here, and haven't been able to find any. They're like really expensive now. I guess they're kind of obsoleted or something. I don't know. Let's try something. I was using some of these guys. I got these ZIF connectors for my FET transistor projects. And it looks like they might work with these guys as well. So here we got a heat sink, and we'll put the device through there like so. I can stick, let's see, I want to put this on here so it's got these pins in here like that, and the lever is still above, so I can flip it down like so, and it will still leave the screw holes open so I can screw it into place with screws. And I think I might be able to use this ZIF connector here on my transistors to hold the pins and then make it easy for me to replace them. I can just pop it up and take the pins out, right? And so we might go ahead and try that one. Okay, let's continue with this project. Okay, so it looks like the emitter is the one with the arrow. Base is the kind of like the throttle of the transistor. And the collector is the one with no arrow on the symbol. And so let's go back to our diagram. So we want to hook the bases together to ground. And if we look at our little diagram here, the base, okay, let's rotate this. Okay, so the base is going to be corresponding to this pin over here, and the collector, or emitter, I guess, the emitter is going to be this far right hand pin. Okay. See, it's above the center on these pins. So I got this in the same orientation. And so we want to tie these collectors together and to ground. Okay, so I'll get, where's my other device? Okay, there we go. We'll get those tied together to ground. Okay. Okay, so we got our soldering iron heating up, and got our two transistors here. And I think we decided that this corner one is the emitter. And we're going to, black is conventionally the ground color. So let me twist this and make it into a loop, like so. And it's usually, you usually get a stronger solder connection when you do some kind of mechanical, also loop or something like that. Okay. And let's see, where's our solder? Okay. So I'll just solder this one on, and I'll just go ahead and solder the other one on as well after this to get the emitters taken care of. Okay. Let's see if I got that on there. Okay. Of course, you don't want the stray wires to contact another conductor, because that would be bad. Okay. Okay, make this into a loop. Loop it around the pin that I'm going to solder it to. And then let's go ahead and solder that. Oops. Okay. And so this will get our collector, or emitters, taken care of on our NPN transistor. Let me put a little more solder on this guy over here. Okay. And we'll move on to the next step. Actually, I think we're going to go ahead and just make sure we have a good connection here. This one's okay. We'll just twist these two together and solder them together as the output. Okay. There we go. And then we'll move on to the next step, building this oscillator. Okay, so I stripped back some wires here and bent them around in a loop so we can get some wires attached hopefully to the collector. So the collector is going to be 1, 2, the third pin in from here. Okay, I got that on there right. Okay. Let's I guess try to solder that in place. Okay. I'll get a wire solder to both of the collectors. Actually, I'm sorry, this is the base, isn't it? This is the emitter, this is the base, and the collector is going to have to be a lug, probably. I'm probably going to have to put a lug onto our shell of this guy. That'll be the collector. Okay. We'll just get these wires soldered up because we gotta get things going here. Okay, so here's my dual potentiometer from Amazon, and I will use this for the tuning. Let's take a look here. I'm going to have some 200 ohm resistors, but I want to tune these two circuits together. I'm going to add more resistance on there, so the high frequency will be at 200 ohms, and the low frequency will be at higher, because it will take longer to charge these capacitors. So I need to have a dual pot here, so it will change the resistance on both circuits in the same way. And let's just take a look here, because I believe we will stick these probes into this guy, like so. Let's see if I can do this. Okay, well, let's just... Okay, so this top row and this top row and the bottom row are completely independent. So if we take our probe here and measure from here to there, see there's nothing on the on our scope, and from here to here, I believe these are the contacts that we want, because as I turn it, let's see if I can get these in there and turn it at the same time. Okay, so as I turn the contacts, see it's 0, there's 10K there. As I turn it that way, as I turn it clockwise, it goes down to 0 ohms. I turn it counterclockwise, it goes up to 10K. So that's the way I want it. I want it so when it goes up all the way here, it's at the high frequency, so the resistance should be 0. So I believe I want to connect wires to these two pins and these two pins, and we'll use those as our variable potentiometer. Okay. So let me get going. I'm going to cut some wires and we'll connect it to this guy. Should be cool, huh? Okay, so this thing actually has some holes here. Let's take a look here. And I was thinking maybe what I'll do, instead of wrapping the wire around these pins here, I can stick it through these holes and just solder it through the holes like so. See if I can get that through that hole. I want to feed it through the back side so I can clip the wires on top. Okay, there we go. See, I got it through the hole, like so. We have our soldering iron here. Let's see if we can solder that wire through there. And I'll get 4 of these wires soldered in place, hopefully. Get them soldered so they're not touching each other. See how that works. Okay, see if we got a good solder joint there. Okay. So there we go. I think I should be able to do the other 4 that way, or the other 3. And we should be good to go. Very cool, huh? Okay, so I have all the wires soldered in place, and of course we should always test our handiwork. Oh. Got this making contact. Oh, come on. Okay. There we go. Okay. So say I turn it that way. Let's just wrap this around here for now. Okay, so I turn it all the way clockwise and it's almost 0 ohms. I turn it all the way counterclockwise and we got about 10K. And I'll just test the other side also, make sure that both resistors are working in unison. Okay, so it looks like that's got good connections there. And I think we're ready to go on to the next step. I might clip these off so they don't short out on something. Okay, very cool. Okay, so again, I want to put some buffer resistors in there so it doesn't oscillate too fast and destroy our circuit. You never want a circuit that's going to self-destruct just by twiddling the knobs, right? And I figured I need about 200 ohms to get the top frequency. And these are, I also did a calculation on the power, and they need to dissipate about 2 watts, a little bit, 1.5 watts or something like that of power, I believe. And so these are 2 watt resistors, and if I put them in series, they'll share the load very nicely. And they're 100 ohms, so I need 2 of them in series to get 200 ohms. So let's pull a couple of these off. And I'll try sticking these in the circuit. Okay. What I like to do, I might cut these off also, is I'm going to, in order to get the 200 ohms, take these resistors like so, and twist the wires. And I can solder these together. There, now we have a 200 ohm resistor. Okay. And we can do it with the other ones as well. There we go. Twist them together, and then we'll just solder them together. Gotta be careful when I grab that soldering iron because I don't want to burn myself. Okay. And there we go. We get a real good solder joint like that. Okay. Okay, so the next thing I'm going to do is I'm going to, well, I'm going to be consistent about this. I'm going to probably attach these resistors here in series with the potentiometer, just like our circuit over here shows. Let's see if I can. Okay, so this is the 200 ohms, and we're going to add the 10K ohms in series with that guy, and again with this guy. Okay, and I'll do that again by taking the wires here. Let's take a look at this, and we'll twist the wires together. And then we will solder this guy up. And I'll probably have to tape these up afterwards. Let's see, where's my... Okay, here's my solder. Okay. Okay, so there we go. And I'll go ahead and do the other wire as well. Get them both hooked up in series with this guy. Okay. Okay, so there we go. I have these two resistors hooked up in series with our potentiometer here, our dual potentiometer. And let's see, so that is this part of the circuit right here, and that's going to connect to, each of these is going to connect to the base of our transistor, and it's going to have a capacitor which is going to do our timing connected to it as well. So let's go ahead, I guess we'll connect these resistors to the base here, and we'll get that step done next. Okay, again, here is our transistor, and here's our diagram. See, it says emitter and base. So this other wire that we put on here is the base, and I'm going to hook it to one of those to that transistor, and one of the other bases to, resistor, and the other one to the other resistor. So we'll get those soldered together, and it looks like this circuit's coming along pretty nicely. Okay, so here's our transistor and our potentiometer with these extra resistors hooked on here. And I'm going to hook, so this is our base wire here. I'm going to hook that to our resistor here. Okay, so I'll take the wire and twist it around and then solder it. Like so. Okay, there it's all twisted. And now okay, so here is our resistor. And see if I can solder this in place. Okay. Okay, there we go. So now we got that resistor soldered in place, and I'm going to solder this other resistor to the other base of our other transistor over here. Okay. There's our second transistor in the socket, and here's our base wire right here. And I'll solder that onto the other set of resistors there. Okay. Okay, so there we go. We got our two transistors with the bases, the base wires here, hooked up to our resistor network here for the timing of the circuit. Okay. And so let's take a look over here at our, so that's this resistor and the 10K, which is also in series with that guy, hooked to the bases of these transistors. And we're going to have to hook up our 0.2 microfarad. Of course, this capacitor is a little bit bigger, so you know I might have to cut out one of those. We'll see how the timing or timing works, because this capacitor is going to be 10% bigger, so the timing may be off. I may have to change one of these resistors out. We'll see. Okay, so I have some legacy Radio Shack. I always like to keep parts on hand, and it's good that I did, because I didn't expect this phony pandemic and communist takeover of America to happen. The communists are really crafty, aren't they? It's a very clever plan to employ the germaphobes to help them take over America and destroy our country. But anyway, soon I think there will not be electronic components available for anything, so I'm glad I stocked up. Okay. Okay, here we go. I guess let's break out the Radio Shack capacitors. I was saving these for a good cause. Whoever thought Radio Shack would go out of business? The world's just gone completely insane. Okay. So here we go. So these are 0.22 microfarads, right? Okay. And remember, we want to connect these at the base of our resistors here. So I will just twist one of these around and solder it in place. Okay, so there we go. And let me get my solder. Okay. Yeah, it's hot. Okay, so there we go. Soldering that capacitor in place. Okay. That should be good and soldered in place, and I'll get the other one on there on the other side, because this is kind of a symmetric circuit. We have a capacitor on this side, capacitor on that side, and the two timing capacitors. Okay, and we'll get that going. Okay, so there we go. Here's our transistors, the base wire connecting to this node right here. And so this node connects the base wire to our capacitor, right? We have our capacitor here to our resistor network. Okay. And we got both of our capacitors on there. And I think things are looking pretty good. Okay, we'll move on to the next step. Okay, so I think I'm going to probably test this circuit with resistors before I start putting transformers in here, because transformer is not technically a resistor. It's more complicated. I'm just going to throw a wild card in there, because this resistor is not only the load, which is going to be 5 ohms to the transformer, but it's also charging this capacitor, and it's going to have less than 5 ohms as an inductor. So it's actually a more complicated circuit. So I'm just going to probably test it with resistors for the load at first and make sure the thing oscillates properly. Okay, anyway, so here's our resistor network and our other resistor network, and they get tied together and go to the positive of our power supply. So here I have a wire here, a positive wire, and I'm going to tie the two sides of our potentiometer together and solder it to this, and that part of our circuit will be done. Okay. Okay, so here is our potentiometer. I'm just going to twist these two wires together. I guess it would have been better if I would have made them the same length, right? What is it? Hindsight's 20/20. Anyway, here is our red wire. Okay, I'll twist that on too. Again, I'm tying the two of the same parts of the potentiometer. This side right here, these two pins, the top and the bottom on the very left-hand side, tying those together. See that? To the same power source, which is going to be this, and then it continues on through the potentiometer, through the middle ones, top and the bottom, to our resistor network here, and the rest of the timing circuit. Okay, so let's do this. So I'll twist this guy, our red wire. I like to use red for positive, so we know that that's where the power goes. You know, one time I worked at a company and they thought that they would save a lot of money by getting wire harnesses, which have about 100 wires in them, and they would get them all the same color. just wait, because they saved probably 50 cents. Of course, it's cost them an extra $10,000, probably extra $1 million, because the project was super late, because you couldn't troubleshoot the thing with all the same colored wires. A bazillion wires, and the thing broke, and anyway, I won't say what company that was. That's good to color code your wires and make it easy on yourself, because when you come back to this circuit in a year or so, if you want to use it again or modify it, yeah, the easier it is to understand, the better it'll be. Okay, so now we have our power wire. We have a red power wire and our black power wires here coming off the other side of the transistor from the emitters. And we'll move on to the next step. Okay, again, it looks like the timing is, I just checked it. Let me see. Okay, so the timing of this circuit does depend critically on this value being 5 ohms. It'll change the frequency if that's not this 5 ohms, which makes sense because that's also charging the capacitor. So we may have some implications when we hook up the transformer to this. So I may have to modify the circuit. We'll see. But anyway, for now, I have these resistors. I was going to do a video on this. I got these off of Amazon, and I was going to, wasn't sure if that was too trivial or not. I did an unboxing and, show the different values that are available here. I might go ahead and post that anyway, in case anyone's interested in these resistors, because they have certain denominations, like about 20 different types or something, and I tell what they are. Anyway, maybe I'll post that video later if people are interested. But it looks like if I take 4 of these and tie them together in parallel, that should give me about 5 ohms, and it would be pretty high power. 1, 2, 3, 4, 5. I got, I think, about 10 of these, so maybe I'll go ahead and do that. Take out 8 of those and twist them in pairs of 4 together, so we can test our circuit out and see if it oscillates properly. And then maybe I'll make a second video on hooking it up to a transformer and the speaker and testing it out. Make sure it produces high power oscillations when hooked up through a transformer. Okay, so let's break these out. And we'll pull out about 4 of them. Okay. And sometimes they work better if you just twist 2 at a time, so maybe I'll twist 2 of these together, like so. And then I'll twist the other 2 together, and then I'll twist all 4 of them together. Okay. There we go. 2 and 2 makes 4. See that? 4. Twist those together. Okay. And let me see. Let me grab my ohm meter back here. I always like to test what we're doing. Let's see what our resistance is. Now remember, when you're taking ohm measurements, you don't want to grab it with both leads, especially if it's a high impedance resistor, because okay, 5.6 ohms, so that's about what we need. So because your body actually has resistance, right? So it's about a mega ohm between your fingers, so it will mess up your resistance if you hold the resistance measurement, I should say. If you hold your components while you're measuring them, if they're of high value. Okay, well, let me go ahead and finish up the second set, and then we'll have our loads ready to test our oscillator. And we may have to make modifications to the circuit when we put the transformer in there, because transformers are more complicated. Okay, there we go. couple 5 ohm loads so we can test our oscillator out. Should be interesting. Okay. Okay, here we go. Remember, clip leads are your friends, especially when you're testing out a circuit. And so I have from the positive lead, I'm running 2 clip leads to our 2 loads here, through the loads, and at this point we just need 1 resistor for each collector of the transistors. And that's almost the complete circuit. There's one more connection that needs to go from the bottom side of this to one of the capacitors, but you have to be careful when you do that, because let's take a look here, because this connection that goes to the collector, this transistor, is going to go to the capacitor of the base of the other transistor, and that's what's going to make it oscillate. And the same thing with this one. So we have to cross the connections when we make the connection from the resistor, the bottom of the resistor, which is our load here, this is our load, to our capacitor here, right, which is going to be these guys up here. So we'll have to be careful to make sure that we get the proper resistor with the proper capacitor, and hopefully if everything's done properly, our circuit will oscillate when we're done. Should be very cool, huh? Okay, so here we go. Again, this is the node between the base of, let's see, this transistor, and we're going to make this last connection to the capacitor connected to the other transistor. Okay, so the collector of one transistor to the capacitor of the other transistor, and vice versa. The collector of this transistor goes to the capacitor on the other transistor. Okay, very cool. I think we're about ready to test this out, and I happen to have a little battery pack with the battery holder that I got from Amazon, and some of these. This is actually 12 volts. These batteries are almost 4 volts apiece. The 18650 3.7. They're closer to 4 volts when they're fully charged, and we can test our circuit with this. So I might get my oscillator out, or my oscilloscope, and we'll see how this thing works. Should be cool. Okay, so here's our circuit in all its glory, and remember, you want to double and triple check everything before you hook the power up to it, because once you hook the power up to it, it is too late. You're going to burn something out if something's wrong. Okay. Oh, look at that. Well, it looks like it's oscillating. 1 microsecond per division. Let's try. What the heck? 2 microseconds per division. Oh, we got to go faster. It's oscillating very fast. Come on. I guess that's as fast as the scope goes. Let's try twiddling the potentiometer here. Okay, there we go. Ooh, we're getting some crazy stuff there. Well, I got this. Should this be about 5 volts per division? Okay. Definitely getting some kind of oscillations here. Not sure if that's what it's supposed to be. Let's change this to 20 microseconds per division. Okay, there's an oscillator. It looks like we're able to change the frequency by twiddling our knob over here. Okay. So it's definitely... Oh. There's the low frequency there. And there is our higher frequency. I'll have to measure that. So again, I'm twiddling the knob here. low frequency. Of course it goes unstable there. And there's our higher frequency. Okay, very cool. So it looks like it's tunable, it looks like it's oscillating, and let's see, period is about 40 microseconds per division, so I have to do some calculations to see what that is. Okay. Very cool, huh? Okay, so there I increased the amplitude 2 volts. It seems like it should be, wait, 2 times 2 is 4, so that's about 4 volts. Let's do 1 volt. So the oscillator is at about 4 volts, even though I'm putting in much more than that. I'm putting in 12 volts, almost 12 volts through this guy. So I was expecting a higher oscillation voltage out of this. Let's check our transistors, make sure that they're not getting hot. Okay. Okay. Let's see what that frequency is. Okay, so I put some new batteries in there. Maybe the other batteries are kind of low. And let's try. See, that looks pretty similar to my simulation. Okay. See, our simulation kind of looked like that. Very similar, huh? Let's see how many volts is that. It's 1 volt per division, so 1, 2, 3, 4, 5, 6. 6 volts. It may not be doing the full voltage swing because we're not driving it as hard as... Okay. That's interesting. It seems to be going up to a higher frequency than I thought it should. Oh. Stupid scope. Okay. Let's see, what frequency is that? I'll pause that. Okay, so that is about, so the higher frequency we were measuring before was about 25 kilohertz, which is what I was aiming for. And it looks like this is 20, 40, 60, 80, 100, 120, maybe 120 microseconds. So we'll see what that frequency is. And there's the whole circuit there. Okay. Some of this stuff in there. Okay. Okay, so that lower frequency that we're looking at was about 7 kilohertz. So I guess that's not too bad. Let's see if we can go back up to the high frequency again. And there's our high frequency, and that one, let's pause that one. Okay. So that one again is about 40 microseconds per period. So that's about 25 kilohertz. Okay. Very cool, huh? I need to put this in the frame. Okay, there we go. Very cool. Crazy looking oscillator. Okay, so that's covering the frequency that range that I want. It's doing some crazy stuff though when it goes out of range, so I may have to tune that. And there's no guarantee that this is going to work when I put the transformer in there the same way. I hope it does, but the transformer's got inductance and other things, and so I may have to tune it around a little bit to make it work with that. So we'll see. Okay, again, I decided to try to hook this up to my Rigol scope. And, okay, there we go. Here it's running, we've got the cursors on there, and it looks like it's about 24 kilohertz at the upper frequency. And again, I can twiddle this frequency dial knob, and Let's see what the lower frequency end is. This knob is kind of not working so well. Sometimes it doesn't go down the way you want it to. Sometimes it doesn't. Sometimes it jumps randomly, whether it goes up or down. Okay. Okay, so that is about the lowest frequency that this thing will go to. Of course, it's going the wrong way. Okay. Let's see, we'll get our cursors in position. So that's about a full period, so that's about 6 kilohertz. So the oscillator is going from about 25 kilohertz to 6 kilohertz with this tuning right here. Okay. And then it goes into noise if you tune it down too low, so I might have to fiddle with that so that doesn't go into that mode, because that's probably sure to break something. Okay, very interesting. Anyway, this is Dr. James, and thanks for watching.